All right, it's time for radical review, a mixture of different square root or radical problems. So in here, take the square root of all of the things in here. So take the square root of 36 is 6. 5, we can't really take the square root of it, so we just go like this and say take the square root of 5. And then for the square root of x to the 9. Well, what square root does to exponents, like if it was, I'll make it an even number, if it was x to the 8, is it cuts exponents in half. The reason it cuts them in half is because the square root can also be written as a power of 1/2. They mean the same thing. If you do it that way, then power raised to a power, you multiply, and 8 multiplied by 1/2 cuts it in half is going to be x to the 4th. What happens when it's x to the 9th? When it's x to the 9th, the 9 can't really be cut in half because then you'd have x to the 4.5, which is strange to have decimals as exponents. So what you do with x to the 9th is you go x to the 9th is x to the 8th and an extra x. That means x to the 9th. And then as we saw with x to the 8th, the exponent will get cut in half. So for this one, it's going to be x to the 4th. And then the rest is going to have the square root of x inside like that. Now once you get used to this, you can go pretty fast. You can go, all right, the square root of x to the 103. So you cut this in half, cut the exponent in half, and let's see, a 2 divided into 103 will go 5 times, multiply 10, carry down the 3, and then it'll go 1 time, and then you multiply, and it's got a remainder of 1. So that means that this is going to be, you cut this in half, it'll go 51 times, a remainder of 1, so 1x remains inside. All right, so you cut this in half, a 2 will go into a 9 4 times, so it's x to the 4. It leaves a remainder of 1, so 1x remains inside. Now technically there is one small thing. We need to rationalize the denominator, it's called. In other words, don't leave a square root in the denominator. So multiply the top and the bottom by the square root of 5. Then on the bottom, you can either look at it as 2 square roots will cancel each other out, or this means the square root of 25, which is 5. Either way, you end up with just the number 5 on the bottom. And then this is going to be 6x to the 4 doesn't change. This should be put together as 5x in one radical, and there is our nice new answer. In order to rationalize this, you can't just multiply by square root of 2, like over here in red I multiplied by the square root of 5. Instead, you have to use what's called the conjugate. And the conjugate is use the 1 and the square root of 2, but use the opposite sign in the middle. So multiply by 1 minus square root of 2. You have to do that on the top and the bottom. On the top, I would suggest you don't multiply it out yet, because there's the possibility that the 3 right here can get canceled. So just leave it like that for now. And then when you multiply this out, you would have the first one times the first one is a 1. If you use the FOIL method, the O and the I, or the middle two terms, are going to cancel. Because look at, when you use the conjugate, this one times this one would be a positive 1 radical 2. And yet this one times this one would be a negative 1 radical 2. They're going to cancel each other out. But you do need the last term. The last term is going to be this one times this one, is going to be negative because it's a positive times a negative. And then a radical 2 times a radical 2 is just a 2. Okay, so it leaves behind a negative 1, which you can actually put in the front of the whole problem. And then the 3 didn't get canceled, so I need to multiply that out. So that's going to be negative 3 and then positive 3 radical 3. So just distribute that negative 3 and then it's done. Okay, for this, you can't directly take the square root of 800, so you have to factor the 800 into something you can take the square root of. And hopefully something that's as big as possible. For example, if you were to factor this as, you say, okay, the square root, I've got 100 times 8. That's 800. And I can take the square root of 100, so that reduces the problem. But the thing is, this still has a 4 in it. So you're still going to have to continue after that. So if you would take that 4 out and put it over here, or in other words, factor 800 as 400 times 2, then you can automatically do the square root of 400 is 20, and then this one would be done. So that's what I'm going to do. So look at it as the square root of 400 times 2, and then for x to the 5th, we'll be cutting that exponent in half. So the square root of 400 is 20, and then leave some space, and the 2 is going to have to stay inside the radical. Next, for that x to the 5th, divide this by 2. It will go 2 times. That means 2 of these go on the outside. It would have a remainder of 1, so 1 remains on the inside. Ta-da! Notice on this one it's the cube root. The cube root of 27 is 3. Cube root means now we divide the exponents by 3. When it's square root, we divide by 2. And when it's cube root, you divide by 3. So if you divide this exponent by 3, it will say x to the 2. And then cube root of 4 is not a rational number, so you have to just write it as cube root of 4. Well, what do we do about this denominator? You can't just use the same thing, because if you use the same thing, it would be this cube root of 4 times itself means the cube root of 16, and there's no cube root of 16. So let's see. You can take cube roots of perfect cubes. So in other words, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. So these are the numbers that you can take the cube root of. So somehow we have to get that 4 to look like one of these. Well, if we just multiply by a 2, we could change it into an 8. So that's what we're going to use. So on the numerator and denominator, use the cube root of 2. As long as you do the same thing top and bottom, that's legal. And so the denominator is then going to have the cube root of a 4 times 2, or in other words, the cube root of 8. And then just recopy the top part. And then finally, the cube root of 8 is 2. So we've got a 2 down here, 3x squared, and then the cube root of 2. And nothing can be canceled, so it's done.